Good day, 10Cs. Welcome back to the world of polynomials. I know everyone's just itching to get started. So last day we reviewed from grade 9 the fact that we can combine like terms, we can multiply and distribute negatives to get rid of brackets. Well, today we're going to focus on power laws, and power laws at times are a unit to themselves, but the reason we're talking in terms of power laws is because we're going to do monomial calculations. Monomials with monomials to start with. And those are your power laws. So let's just jump into it. We are looking at today page, I want to say page 12. I hope I'm correct. I think I even would suggest you start on page 12. That would be a good place to start. And we'll look at multiplying, dividing, and power of power. So when we are multiplying monomials, what we have here is we have a single term, which we talked about previously, big numeric coefficient variables as a multiplication chunk, and we're going to multiply that by another term. So it's one term monomial times one term monomial. Remember, when we're multiplying powers in this situation, what we want to do is we have to multiply the coefficients, but we add exponents on powers with like bases. So in this case, if it helps also, powers by themselves have exponent ones. So all the work involved with this question, we want to multiply the coefficients, 3 times 7, and then because everything's multiplying, we're going to add the exponents. We have an x to the 1 and an x squared. So we would add those exponents. We then have a y to the 1 times another y to the 1. So we would just go y and we would add exponents. And that's all done, we would have 21 x cubed y squared. Monomial times a monomial, multiply coefficients, add exponents. The second example here is really no different. Second example though, fraction work. We still want to multiply the coefficients, would be 2/3, not 23, times 9. Well, fraction work, 9/1 gives us a fraction. Remember, we can reduce if possible first. 3 and 9 can both be reduced by 3. 3 reduced by 3 is 1. 9 reduced by 3 is a 3. So that simplifies our multiplying. 2 times 3 gives us 6. 1 times 1 gives us 1, which simplifies to just 6. And then we have an x times an x. Don't forget these exponent ones. That would become 1 plus 1 with our exponents. Multiplying gives us 6x squared. Multiplying monomials, seen it before. Dividing monomials, same kind of idea. This, because they're monomials, we could argue are kind of like powers with coefficients. What do? We divide the coefficients and we are going to subtract exponents on like bases. This question here could have started as 34x4y divided by 17xy. However, I like writing them in fractional form because then it's nice and easy to have things lined up. Divide coefficients, 34 divided by 17. We have an x1 on the bottom, so we then are going to go x to the 4 divided by x1, which would leave us with subtracting the exponents. And then we're going to have y1 divided by y1, and that leaves us with y1 minus 1. When we take a look at this, 34 divided by 17 is 2. x4 divided by x1 tells us to subtract exponents is x cubed. And y divided by y, well, that becomes just y1 minus 1, which is a y0. So to fully simplify, 2x cubed and y 0 times, we really don't even need it right now. Simplified form would be 2x cubed. So the second example, same idea. Divide coefficients. Negative 36 divided by 9, there's negative 4. And then m cubed divided by m squared. Subtract exponents. 3 minus 2 is an m1. Technically, that's acceptable, but multiple choice answer would simplify it to just negative 4m, because the 1 would be assumed to be there if it wasn't. Negative 4m, which is the same as negative 4m to the 1. Dividing. Not rocket science, but the repetition in practice is important. So now, sometimes we have powers with monomial bases. So we have a single term monomial, 3x squared, to the exponent or power of 4. Well, this is also referred to a situation like this as power of a power. When a power acts as the base within a bigger power. That's what we're looking at doing. Well, the simplest way to deal with power of a power is the fact that every exponent in the brackets multiplies by the exponent outside the brackets. So you have to be careful in this base. You have the exponent 2, but you also have an exponent 1 on the 3. So the exponent outside multiplies by each exponent on the inside. So we would have 3 exponent 1 times 4, and the x would be exponent 2 times 4. Well, we want to simplify. 1 times 4 leaves us with 3 to the 4, and then x 2 times 4 leaves us with an x to the 8. Last thing though, if you have a power that can be calculated, you should always do it. 3 exponent 4, 81, x to the 8. There's your simplified power. Every exponent in the brackets has to multiply by the exponent outside. So if we take a look at the second example that's there, how many exponents are inside the brackets? Well, don't forget your coefficient has an exponent 1 and the x has an exponent 1. So this 3 on the outside needs to multiply 3 times. We end up with 2 to the 1 times 3, x to the 1 times 3, and y to the 3 times 3, which gives us a y9. Not completely simplified because we have a power with a numeric base. 2 cubed is not 8. Sorry, it is 8. It's not 6. Popular answer is 6. Remember, it's 2 as a factor 3 times. 2 times 2 is 4 times 2 is 8. And we still have x cubed y9. 8x cubed y9. Power of powers. So sometimes if we go to page 13, a practice page, sometimes there's more than just a monomial and a monomial. Here, we have to be careful because we have 3 monomials all being multiplied. I often get students that want to do distributive multiplication. We're going to talk about that in a second, but 3 would only be distributed if I had a binomial inside. 3 times a 2 term. That's when I would distribute. But that's not what we have here. It's a 3 times a 5a squared b times a 2ab. This is all one big chunk of multiplying. It's kind of like if I had 2 times 3 times 4. 2 times 3 is 6. 6 times 4 is 24. We don't do 2 times 3, 2 times 4, and then multiply that. It's just multiply everything at once. So this, multiply the coefficients. 3 times 5 times 2. I have a variable of a with an exponent 2 and an exponent 1, so I would add them because they're being multiplied. I have a b1 times a b1, add the exponents. That leaves me with 30 a cubed b squared. Only distribute if it's a single term times multiple terms, and we're going to get to that in a minute. Here, again, page 13, question I. This one's a little unique because we have a power of a power. I suggest you always look to do power of a power first. We then have to multiply as a second step. So if I do this power of a power first, remember, every exponent in the brackets has to multiply by that 4. So we would have 2 exponent 1 times 4 and x exponent 2 times 4. 2 exponent 4, 2 times 2 is 4, times 2 is 8, times 2 is 16, x to the 8. But we still have to multiply by this second monomial now. Now it's just multiplying, so it would be 16 times negative 3, which is negative 48, and x8 times x cubed, add exponents, negative 48, x to the 11. Look to do power of a power first, and then multiply or divide as second steps. So at this point, monomial calculations. Complete page 13, a few questions on there, not too involved, but answers are there. Please note, there are 3 little errors on the answers. So make sure you write those down so you don't get frustrated. So once you're finished that, turn the page because we've got a little bit more to go here. This monomials times polynomials is a bit of an add-on. If you want, I suggest you turn to the back of your booklet. Page 28 is where you're going to find this question. So 28, here's where we have a monomial times a multi-term polynomial. B plus C or W times X minus Y plus Z. Monomial times a multi-term 2-term. Monomial times a multi-term 3-term in this case. This is where the distribution comes in. Each term in the brackets has to multiply by the term outside using the rules we just talked about. So if we take a look at question number 2 on page 28, how many multiplication steps will there be here? Well, what we have is the monomial 9y squared times a 3-term trinomial, and that means we're going to have 3 multiplication steps. That's what you're going to have to do. 9y squared will have to multiply 3 times. I wouldn't expect to see all this work. You need to become proficient at it, but here's the 3 multiplications that would occur. 9y squared is going to have to multiply by the 7y squared, 9y squared times the 5y, and 9y squared times the negative 3. We just talked about it. Multiply coefficients, add exponents on like terms. Multiply coefficients, add exponents on like bases. Multiply coefficients, add exponents on like powers, and there we just have a y squared. So there's our 3 terms. we end up with 63 y4 plus 45 y cubed minus 27 y squared. There's a monomial times a trinomial. Remember the distribution. Try number 22, page 28. Stop the tape, give it a try, and then come back and we'll look at the steps that I'm going to do. Again, it's a monomial times a trinomial, 3 multiplications. If it helps to jot your steps down on the side, do it, but you need to become proficient at this. I still like to put in my missing exponent ones so I don't forget about them, but monomial times the 5rs, negative 45. R squared, S4, and t squared times nothing is just a t squared. Now the next multiplication, negative 9 times 2 is a negative 18. R by itself has nothing to multiply by. S to the 4 and t cubed. T squared times t, t cubed. And the last multiplication, monomial negative 9 RST blah, 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 times the negative 8 RT. Negative times negative, watch your signs. Positive 72. R times R is R squared. S cubed times nothing is just an S cubed. And T squared times T1 is T cubed. At this point, look, are there any like terms that could be combined from the other day? After multiplying, can you simplify further? But what I have, R squared, R S4 T squared, R S4 T cubed, not the same, and R squared S cubed T cubed. No terms are the same. Nothing can be combined. So there's our answer for the monomial times the trinomial. Second part to this is a polynomial divided by a monomial. It's what I call distributive division, even though that's not really necessarily a term, but it's when you have multiple terms, like a binomial, being divided by a monomial C. So in this case, we have to make sure that each term divides by the monomial. That C needs to divide into the A, that C needs to divide into the B. So A divided by C would be done, and B divided by C would be done. So it's a lot like distributive multiplication. It's just make sure you divide every time. So in this case, we have the binomial, so we're going to have to divide twice. And again, I wouldn't expect, and I really would discourage showing all these steps. I'm just going to show them the first time because you need to become proficient at this, and showing all of these steps and not doing it in your head is just going to slow you down. Just talked about division, divide coefficients, and we subtract exponents on the like basis. Here, 27 divided by 9. R squared divided by R squared is an R0. And S5 divided by S squared, subtract exponents, S cubed. And again, the first expression we got, technically this one's not really necessary, and the R0 is definitely not necessary. So when we divide here, we end up with 2R squared S plus 3S cubed. Not like terms, so our division leaves us with a binomial. Take time, give this one a try, and then we'll talk about it together. We have to divide each expression by the negative 8 x cubed y cubed. Watch your signs. 48 divided by negative 8 is negative 6. x9 divided by x cubed, subtract exponents, is x6. y4 divided by y cubed, subtract exponents, y1, or just y by itself. We then have negative 32 divided by negative 8, positive 4. x5 divided by x cubed, subtract exponents, y9 divided by y cubed, subtract exponents, and z divided by nothing just leaves us with that z. Again, no like terms, two separate terms, we end up with a binomial. This is not really complicated math. I can't stress enough. You really should be doing this without a calculator. Check your answers and go back with a calculator afterwards. I can't monitor it, but if you're using your calculator for these little calculations, you're in big trouble later in this unit. You need to know your basic facts. So there's some work. Keep you busy for a day or so. And then after that, we'll come back and we're going to look at some new stuff using the skill sets from today. Binomials times binomials and trinomials times trinomials. Sounds exciting, doesn't it? You're just going to have to wait. Have a great day.